We're asked here, how many ways can 7 people queue up if 3 of the people must appear beside one another? So we can imagine these 3 people, maybe they're friends and they're going, to the cinema, or they're going getting on a bus or something like that, and they're queuing up and they're all going to be together regardless of the order of the queue. And so one possible example of this queue could look like this, where we've got 3 random people here who can appear in any order, and then we've got these 3 blue ones which all always need to be together. But the one thing to keep in mind here about these people is that they can also appear in different orders as long as they're together. So we've got 1, 2, and 3 here, but what we could also have is basically these 2 guys switching positions, or we could have the third person moving back to where the first is and switching with them. And so the first thing we're going to do to address this is we're going to basically treat these 3 people as one kind of segment of the queue. So we're just going to have them, and then we're going to have this individual here. So we've got 1, 2, 3, 4, 5 kind of sections of the queue, because these people can appear anywhere. And then we've got the 3 who have to appear together, and then the 5th one up here as well. And then we want to multiply all these. So we're going to have 1 times 2 times 3 times 4, which is the 4th segment of 3 people, times 5, and that's going to be equal to 5 factorial. And then finally, just to account for the fact that these 3 people can also switch positions, we're going to have to multiply the number of choices we have for this kind of mini queue as well in this segment. So we would have 3 choices for the first of these 3 people, then 2, and then 1. And so what we also need to do is multiply this 5 factorial by 3 factorial to account for the fact that these 3 people can also be rearranged within the queue as long as they're together. And so when we actually put this in the calculator, we're going to get that our answer is going to be 720. So that is the number of ways we can arrange this queue.